right, this is Honors Algebra 2 Pre-Calculus. We're doing section 1.1 in Algebra 2, which is tables and graphs of linear equations. So I'm not actually supposed to talk to you about the linear equation forms yet. Technically that comes up later, but I am not necessarily one to follow the book. So we're going to start by talking about the three different common forms that you'll see of linear equations and a little bit of some pro-con lists of why they're useful. Ignore the huffing and puffing in the background. That is my very old dog. So let's start with the one you're probably most familiar with, which is slope-intercept form. So slope-intercept form looks like this: y equals mx plus b. And it's called slope-intercept form because the m gives us the slope as the rise over run of the equation, and the b gives us the y-intercept. So again, named slope-intercept because it gives us both the slope and the intercept. Most things in math are named either after a person, like Pythagorean theorem or Pascal's triangle, or they're named after exactly what they give us or what they do or how they function in some way, right? So here slope-intercept is so called because it gives us the slope and the intercept. So here are some good things about this equation. So some pros about this equation: number one, it's easy to graph. So if I give you slope-intercept form, it's easy to graph because you start at b on the y-axis because it is the y-intercept, right? And then you move m units as the rise over the run, and that'll get you to your next point. So it's easy to graph. The second reason this is useful is it's really good for word problems. Because in word problems, we're very often given the slope and the y-intercept in some kind of code. So the slope is usually some rate of change. Slope is usually some rate of change. You'll often hear the word per. So something per something, miles per hour, dollars per day, dollars per week, something like that. And B is usually some flat rate, or you might hear initial fee, or starting cost, right? Or one-time fee. Okay, so that's usually our B. So slope-intercept is useful in word problems because very frequently you're given both of these pieces of information in the word problem. All right, so let's talk about point slope, which is my personal favorite. So point slope is y minus y1 equals m in parentheses x minus x1. So here, m is that same slope that we learned about in the last form, and the point x1 comma y1 is a point on the curve, okay? So when we talk about the pros, okay, the first pro here is that it is also easy to graph. It's exactly the same set of rules that we just saw in the other one. It's easy to graph because instead of starting at that point b on the y-axis, we just start at the given point, x1 comma y1, and then we move m units the same way we would if we were graphing in slope-intercept as a rise over run. The second reason that this is super duper useful is that in higher level math, you're going to want to do as little simplifying of quantities as you possibly can. And what I mean by as little simplifying as possible is that if you're asked to find the equation of something and you already know the point and you already know the slope, it's easier to leave this as point slope rather than to simplify it in any way. So this is useful in higher math because you don't have to simplify. So no simplification equals fewer silly errors. Because as you get to higher level math, what you're going to find is that you make the dumbest errors. Like the harder the math you're doing, the sillier the mistake you're going to make. You're going to add 2 and 2 and get 7 when you did something incredibly difficult in calculus class. So we'll find that as we move forward in math, we're going to prefer point slope form. It is by far my preference, so I'm going to put a star next to that for being the most useful of the options. The last one we're going to talk about is standard form. So standard form is usually something akin to ax plus by equals c. And in this situation, a is just the coefficient of x, and b is just the coefficient of y, and c is just the constant. But what I want you to notice is that a, b, and c don't individually give me a ton of useful information. So pros, pretty much none. This is useless, okay? So when you're going to see this particular form of the equation is usually when you have a teacher that says something like, put in standard form, blah, 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 which is not a thing I'm ever going to do to you. Certainly a multiple choice question could ask you to do that. But standard form is pretty much useless. If you're given this form, you're most of the time going to solve this to make it look like this so that you can graph it more easily. it's not a particularly useful thing. When teachers ask you to put things in this form, they're usually doing it to test if you understand the rules of equality, like if you understand how to add or subtract things to different sides of an equation. Again, that's not a thing I'm generally going to make you do, but you should be aware that this is another form of a linear equation. Cool. All right, so what we're going to do moving forward is we're going to work through some examples doing graphs and tables of linear equations and talk about how you can spot a linear equation from a table just from the information that you're given. And that's basically the gist of it. One thing I do want you to note that's common between all of these is that what makes an equation linear is that it has some constant slope, meaning a rise over run. So before we move on, let's talk about that slope for a second. And then we will move on to other examples in another video. All right, so when we talk about the slope of a linear equation, right, we usually abbreviate it m, right, and it represents the rise of the line over the run, which sometimes you'll hear as the change in y over the change in x, or y2 minus y1 over x2 minus x1. Now what that looks like on a graph is if I have some point here, x1 comma y1, and I have some other point here, x2 comma y2, the line between them has a slope of this much rise over this much run, okay? So that's how we would describe the slope, is rise over run. So we'll do more examples of that, but that's what we mean by slope, and that's what makes something linear. We will also talk about the two special cases of lines, right? So a horizontal line, which looks like this, and has no rise, so its slope is 0 because it would be 0 over some amount of run. And we'll also talk about vertical lines as we move forward. Vertical lines look like this. They have no run, and that means that the slope is what we call undefined. And we'll talk about that as we move forward, okay? So again, we'll address all of those later in chapter 1, but that's a quick intro to linear equations, and we'll move on from there.